Welcome to the car hacking village of ROOTCON. This is Jay Turla, and we'll be discussing automating your CAN bus hacking. First of all, who am I? I'm Jay Turla slash Jetman or Shipcode in ROOTCON. I'm currently working as a principal security consultant in Viking Cloud, and I'm a ROOTCON Goon and CFP review board. I've been in an international speaker for conferences like DEF CON, HitCon, ROOTCON, SynCon, NalCon, besides Myanmar, DragonCon in Hong Kong, and other conferences. I'm also one of the admins for the AdVulcan team. We place as finalists for the Hackasat last 2020. It's a space security challenge for the US Air and Space Force. So as a disclaimer, I am not really a Python expert and I do not claim to be one. I just use it for my proof of concept for my hacks or vulnerabilities that I found. My basic knowledge for it becomes useful when debugging or fixing available exploits in the interwebs. The good thing about it is that it allows me to fuzz, because in network and web penetration testing, fuzzing is important. And then there's a lot of modules that I can leverage for my automation and scripting. So because we are talking about CAN bus hacking, we need to understand that cars are computers too. So examples of this are the telematics, you have the advanced features, the infotainment and entertainment systems, you have the safety controls, the emissions, the cruise control, the anti-lock brake system or the ABS, then you have the airbags, the instrument clusters and panels, and the ECUs. As what you can see from the picture, you can see from your screen, these are actually some devices that are actually computers. So you can see that we have infotainment system and we have a couple of ECUs and some instrument clusters. And actually, if you try to interact with them and if you try to use the CAN bus tools or sniffers, you can actually see CAN bus traffic from them. So what is CAN and ECU? CAN is the controller area network for your car. It's like the nervous system of the car and is connected via CAN bus. ECU, on the other hand, is the electronic control unit. They are a set of microprocessors, and that the CAN bus protocol allows the ECUs to communicate to each other. A modern car can actually have like 50 plus ECUs. In fact, Tesla has like 100 plus ECUs. Sample ECUs are the airbags, the infotainment system, etc. So Dr. Ken Tendall from the Canis Automotive Labs, he's the CTO over there. He said that the CAN bus is a protocol used in hundreds of millions of devices, including cars, trucks, buses, construction machines, ships, tractors, and spacecraft. There is even a CAN bus orbiting Mars. Right, so this is a sample of the CAN frame. And if you want to head on to the Wikipedia that I've sent, that's actually the reference. So you can see that in a CAN bus or in a CAN frame of the CAN bus, you have the data, and then you have the CAN high and the CAN low, and you have the arbitration ID and the data. I'll discuss more on that later on. Then these are my favorite CAN sniffers and tools. You have the NanoCAN, which is a $5 CAN sniffer. You just need a Arduino Nano and an MCP 2515, and then you can already solder it, and then you have a $5 CAN hacking tool or CAN sniffer. Then you have the CANTAC, which is one of my first CAN sniffers, and then STM32 CAN sniffer by TechMaker. This was given to me by my friends from TechMaker, and it's a very good CAN sniffer. Then you have the Value CAN 4 from Intrepid Control Systems, which I bought during DerbyCon. This is also one of the most exceptional hardware that I have. It's a fully featured computer, in fact, a Linux computer that plugs directly into your car. So it's on BeagleBone Black, and then it's also wireless via USB-A socket. And then there are two interfaces for it. There's two CAN, one no, I mean there are not two interfaces, but there are interfaces for two CAN, one SW CAN J1850. You have the LIN and the ISO 9141, and it costs $169 only. If you want to jump into car hacking, here are some of the tools that you can use. And Awesome Vehicle Security from Jared the Coder contains libraries, tutorials, and some resources to start car hacking. Of course, if you try to install CAN utils, which allows you to use socket CAN, which is a driver for Linux. You have the CAN dump, you have the CAN player, you have the CAN send, the CAN gen, and the CAN sniffer. These are one of the tools that you need to jumpstart if you want to interact with the CAN or the socket CAN for Linux. So what did I do first when I started with CAN bus hacking? I started with NanoCAN plus instrument cluster because it's easy to do that without harming your actual car. For an instrument cluster, it comes cheap. You can buy an instrument cluster for like $25 and you can already try to fuzz it or try to figure out how you can move the panels on it. Using NanoCAN, I was able to fuzz the instrument cluster and do an actual fuzzing on an actual hardware. So how do you create your own low-cost CAN sniffer or fuzzer? So you just need a NanoCAN bus board from internet, or you could ask from me. So you just need to solder the two components, which is the Arduino Nano on top, and the MCP2515, which is the CAN bus module, and more info from the /minternet/nanocan from GitHub. And of course, the additional component that you can buy so that you can plug this to your OBD2 port. You just need to solder or attach the wire to pin 6 to CAN high of the MCP2515, and then the pin to pin 14 for the CAN low of MCP2515. And then after you were already able to put all the pieces together, you just need to upload a code using Arduino IDE. There's a sample CAN sniffer by Mintonet. It's on CAN receive all. And then I also made some sketches from ROOTCON Lab /car hacking so that you can try to fuzz some of the two instrument clusters that I have. One of that is a Mazda 2 instrument cluster and a PG208 instrument cluster. All right. Now let's talk about automation because that's our topic, right? Automating your CAN bus hacking. All right. So first of all, we're going to use CAN-SEN. This is a sample fire hose attack that allows you to DOS your car. It may not work on recent cars, but in older cars, it should work. This is called a fire hose attack. So using bash, you're going to send arbitration ID 000 and 8 bytes of data with 0. And you can cause a DOS for that. Now, one of the things that I like as well is the Python CAN. And there's a good library documentation about it. Here's a sample code that I made. And I'm actually sending on the interface vCAN0, which is the virtual CAN, and sending the ID 20, and then the data 0 times C0, 0 times FF, and 0 times EE. And that's when you try to do a CAN dump on the virtual CAN interface, you can see from there that it spells coffee. So the interface is on virtual CAN because we are just testing it. And then we have the arbitration ID, which is 14. Now, you might be wondering, why is it that 20, I send arbitration ID 20, and then from the CAN dump, I got 14. So 20 is the decimal, so it's converted to hex, so that's why it's 14. And if you just write the 0 times, for example, C0, it will not be converted to hex directly. It will just become hex. So you have C0, and from the actual dump, you got the C0. So that's why it's spelled as coffee. But if you write 0 times 14 on the arbitration ID, it will become 0 times 14. Okay, this is another way of fuzzing by using Python socket, Python can, I mean. So we're sending 100 can frames using the hex arbitration ID 0 times 69, and then the data 2 bytes of data lead. So this is a sample of just fuzzing 100 can frames. So we are trying to spam the bus with it. You could also iterate a lot of ranges for this. Now, this is also another one that I love. It's easy to code with this one. PyVit. The developer for this one is the developer of Cantac. And this is a sample sample snippet or code using firehose attack. So I'm importing PyVit and using vcan0, which is my interface, and then sending the arbitration ID 0, and then 8 bytes of data with 0, and then sending it in a loop. So yeah, that's a sample of the firehose attack again. Now, this is a sample of an ECU hard reset. It is a vulnerability if it can be sent via the dirty side. Example, the OBD2. So how do you know if it's successful? The positive reply from the frame should be 025101 via the arbitration ID 77A if it's on 7DF arbitration ID. So that's the standard for the UDS message that I'm sending. And as what you can see from the frame data, you have 02, 0, 11, 11, 11, 1, and then the rest are in zeros. So this is a sample of an ECU hard reset, which performs a hard reset to reinitialize the hardware core of the system. It's pretty much like a power reset on the ECU. So yeah, as you can see, it's very easy to just write this POC using PyVit. Then there's another one from Scapy. I haven't tried this one, but I've seen the documentation and it looks cool as well. So that's why I just put this one on the slide. There are also common enterprise tools on the block. We have the Vehicle Spy and the Canoe. Vehicle Spy is also a good tool. It's scriptable. And then you have the Canoe, which is probably one of the tools that I see used by good hackers that I know, car hackers specifically. And then you have the Vehicle Spy X. It's actually a new product from Intrepid. Vehicle Spy X allows you to use any module within its core via scripting in Python, which is cool because you can actually script using Vehicle Spy X. There's also an easy way to program ValueCan4 in Python using Raspberry Pi Linux. There's a documentation about it. This is the sample snippet. And yeah, so of course, Vehicle Spy is in Linux, is in Windows, I mean. But this is the easy way to work with ValueCan4 in Linux. And also, I would like to share one of my favorite car security exploration tool, Carrying Caribou. The reason for that is it's a Python tool, and it's easy for me to use it because it allows me to discover UDS message by sending diagnostic session control if I'm using the UDS discovery module. So there's a lot of modules that you could use for Carrying Caribou. There's also hard reset, there's tester present, and a lot of discovery process and fuzzing for car hacking and automating your canvas hacking, of course. Metasploit is also a good tool if you want to try out some of the post modules that it has. So we thank Craig Smith for developing the hardware bridge during his stint at Rapid7. And from the screen that you can see, this is the hardware bridge RC that will set up a resource script or a web server to bridge communications to a hardware, particularly an automotive, and will also establish a session to the hardware bridge server. So it's generally used for car hacking with MSF. And then from the right side of the screen, you can see that that's a screenshot from the Metasploit module that I made as well. That's the first car hacking Metasploit module that I've made. It's the Mazda 2 instrument cluster accelerometer mover. It allows you to interact with the instrument cluster panel of your Mazda 2. And then here are the current modules of Metasploit. If you just use search automotive, you can actually see these modules. This is a sample template if you want to create your own Metasploit module. So it's easy. You just need to put on your update info, the description, the license, the author, the platform, the session types, and then register options for the options that you can use. And then from what you can see there, I'm actually sending the arbitration ID 202, and then you've got the data next, which is 6001, 6001, 606060606060 and 00. So that's a total of 8 bytes of data in the CAN frame. All right. Just now, I've actually contributed another module, which is the ECU hard reset. I'm sending an arbitration ID by default to 70F, and I'm sending 021101, which is the standard for doing an ECU hard reset in the canvas. And yeah, take note of this. Right now, for new modules of Metasploit, you need to write notes and the stability, the side effects, and the reliability of the exploit module. So that's how they become strict right now. There's also a new CAN Pico board. It's